welcome to All Chemistry. So after a long time I'm making video, so sorry for that. After that my videos will be frequent and I will go frequently. Okay, so I am starting now with reactivity at carbonyl center. Now for reactivity at carbonyl center, why we are starting this? I am continuing actually the carbonyl series. So basically we are going to study about this because if you go to see any kind of chemical reaction, any kind of named reaction, anything containing carbonyl group, so you have to know that where that particular nucleophile will attack and at which rate it will attack and how it will attack. And that's why I have taken here a few carbonyl centers. So I have four carbonyl compound. In these four carbonyl compounds, what is happening, that part is same. For this, as you can see, that part is same. So here if you can see, that part is same, but the difference is in this part. Difference in is this part, that chlorine part, the difference makes. Here chlorine is present, but in other case we have other compound, means we have here a ester group, OCOR group, and here we have another OR group. Here OCOR group and here a OR group is present and another NH2 group is present. Now the thing is, whenever we are considering that carbonyl group, we have to go for the reactivity of the center. Now in case of reactivity of the center, means reactivity of which center? Reactivity of this carbonyl center. This is our point of reaction whenever some nucleophile is attacking. Now we have to see the electron density at the center. So to see that electron density, now go for a detailed discussion for each of this element. Okay, so as you can see here, we have this compound, we have this and this. So here chlorine is present. Now is in case of chlorine, you can see here chlorine, two lone pairs are present, and here chlorine can donate to this bond as well. This can go to the this resonance with carbonyl compound also. Okay, so now here we have this. In case of this group, this oxygen lone pair can go to the resonance with this keto group and the around one this keto group also. In another case, here we have OR only, so that OR also can go to the resonance with this keto group. And in case of this, we have amine. Amine can go to the resonance also with the carbonyl group. Now the thing is, we have first of all nitrogen with less reactive, less electronegative than oxygen. So if we are going to see the electronegativity trend, so nitrogen is less reactive than oxygen. So nitrogen is less reactive than oxygen. That's why what will happen, the tendency to giving electron will be higher in case of nitrogen than oxygen. Now we have various groups in case of oxygen, and in that various groups we have first of all an ether group, that is OR. Then we have an ester group. Here oxygen can go to both side resonance. And we have then chlorine group, and chlorine is the highest reactive, highest electronegative one. So in case of electronegativity, the trend will be nitrogen, then oxygen, then chlorine. Now the electron giving rate will be least for chlorine. So electron giving rate will be least for chlorine, then it will be oxygen, and then it will be nitrogen. Now if we want to go for how electron will be donated to that carbonyl compound, so the mostly donating compound will be NH2. So in case of, if we are seeing that electron density at that center, at this carbonyl carbon center, because whenever we have an we have an outside nucleophile, when our outside nucleophile will attack, in these cases what will happen, that nucleophile will particularly attack this place. This place the nucleophile will particularly attack. Now the thing is, whenever we have higher electron density at this carbonyl center, so the attack will be less. Now going to this, what will happen, NH2 will be NH2 will donate its electron to the carbonyl compound the most. So in case of donation tendency, if we see the electron density at this carbon center will be highest. So electron density at this carbon center will be highest. So if we are seeing the electron density, so electron density trend at the carbonyl carbon center will be this. Now want to see the trend of upcoming nucleophile, that how will it attack. So that trend will be particularly nucleophile can attack to the particular carbonyl center. Most attacks will be happened this center, then this will be the tendency to be attacked by an external nucleophile. Now the thing is, how IR value will vary with that. Now if we going to see about IR value, so what is our CO will be higher for double bond, then stretching frequency of single bond will come. Now in case of stretching frequency of double bond then single bond, the more single bond character it will get, the stretching frequency will be lower one. So if we see the electron giving tendency is highest for this nitrogen. So single bond character will be highest for this carbon. Okay, so as getting a highest single bond character, its highest stretching frequency will be near about 1690. Its stretching frequency. So as you can see here, it has 1815, then 1800, 1740, and around 1690. Acid group and acid chloride group. So we have C double bonded O with this OH. So this is an acid group. We have a group here, okay, and we have an acid chloride group with it. So we have an acid chloride here, double bonded O. So we have acid chloride, okay. Now looking at that, you can see here, so if we are going for this, so for OH and chlorine. Now for OH, what we have? We have oxygen. So oxygen is lesser in reactive than chlorine. So chlorine is higher in electronegative than oxygen. Chlorine is higher in electronegative than oxygen. Negativity than oxygen. Now suppose hydride is attacking. So if we are considering a hydride, so in case of a hydride, so what will happen? In case of reduction reaction, in reduction reaction, what happen? In case of reduction reactions, we have that any hydride that will attack to the carbonyl center, and that hydride whenever is attacking to a carbonyl center, so what we have? We have suppose an acid chloride and an acid. Okay, so for this we have here a, with it we have a OH, means we have a acid group. Here is a R or anything, and we have in other hand we have acid chloride, C double bonded O and chlorine. Now the thing is, whenever some attack will happen, so this case what will happen? Oxygen is lesser in electronegativity than chlorine. Now hydride will attack. Now suppose the hydride is selective and hydride can attack to the lesser electron dense carbonyl, means where electron is less at carbonyl center, there hydride will attack. Now so if we go for resonance type of thing, so in case of oxygen, we have here oxygen is going to resonance with that double bond. Now in another hand, oxygen is lesser in electronegativity than chlorine, so chlorine can also go to resonance with a carbonyl group. Now the tendency to go to resonance is higher in case of OH. Now so a hydride is selective to a center, it will attack to a center where electron density is lesser. So now we have an hydride here, so it will attack to that chlorine bearing carbon more frequently than OH bearing carbon. So now suppose we have NaBH4, okay, and in case of NaBH4 we have two groups here. CO2H, CH3, whole 4 and COCl. Now here we have added a hydride like lithium borohydride LiBH4. In case of LiBH4, NaBH4, anything that will particularly attack where, which center is more reactive towards that nucleophilic attack, towards that hydride attack. Now in acid group and acid chloride group, in between acid CO2H group and in between COCl group, which center will be more reactive? That carbonyl center bearing chlorine will be more reactive, because chlorine will go to less resonance with that carbonyl carbon. That carbonyl carbon bearing chlorine, because chlorine is higher in electronegativity, it have less tendency to give its electron. So at chlorine bearing carbon, the electron density will less. Now we have an external hydride here. So it will first attack that COCl. It will not attack to the CO2H. It will first attack to the COCl. Now if we go for this, if we go for the reaction where we have two groups, CO2H and COCl, so where that hydride, first of all the reduction will happen? The reduction will happen there containing COCl group, H2OH. So that will be the answer, CH2OH. Now how these reactions happen? O, Cl here, then H minus will come, okay. Now that H minus will attack to this center and chlorine will go out. So what will form? CHO will form. So C double bonded O and another hydrogen there. And in next case, here another H minus will come and this will attack to the aldehyde and this will go up in presence of H plus in the medium. So we will get CO2H, CH2OH. So here is CH2OH. This is the mechanism, okay. So thank you for watching. That much for today. I will come with many reaction mechanism in the next day, and thank you very much.